So, hi everyone, welcome back. So, let's start with the new Eon topic, which is desperate remedies. So, let's see what its whole for is. And one more thing, uh, as this is a completely scientific topic, I'm not too good in this. That's why I'm using a Cambridge dictionary for many of the words. So, let's start. In order to make a headway on knotty metaphysical problems, philosophers should look to the method used by scientists. So here the meaning of the knotty means a very the unsolvable problem. So here the author is talking about this whole eon is about unsolvable mystery of metaphysical problems. So let's see, and it is written by Nina Emery is a professor of philosophy at Mount Holyoke College in South Hadley, Manchester. She is the author of The Naturalism Beyond the Limits of Science and How Scientific Methodology Can and Should Shape Philosophical Theorizing, which is written in the year 2023. So let's start with the four species of this eon topic. When radioactivity was discovered at the end of the 19th century, it surprised scientists. Radioactive decay could transmute one element to another. A conversations previously thought possible only in the dream of alchemists. In the process, mysterious beams of energy were emitted from the source material, being that were at first mistaken for a type of light, but they soon revealed to be something else altogether. By examining the extent to which these radioactive emissions were able to penetrate other materials, scientists realized that there were different types of decay. Alpha decay resulted in emission that could be blocked by a thin sheet of paper, whereas gamma decay resulted in emission that could not be stopped by anything short of a very thick layer of light. So, this what it says, when radioactivity was discovered at the end of the 19th century, it surprised scientists. So, it is a very surprisable for the scientists, this discovery. Radioactive decay could transmute one element to another, a conversion of previous thought possible only in the dreams of alchemists. So, what is a decay firstly? So let's see what decays means. It means to become gradually damaged, worse or less, to cause something to do this. Just like a sugar makes your teeth decay. Okay, got it. So radioactive decay could transmute one element to another, a conversion previously thought possible only in the dreams of alchemists. Who are the alchemists? Most of you know that because the one popular book, The Alchemist, everyone knows, most of you knows who are these persons. A person who use or seems to use alchemy, attempt to change ordinary metal into the gold. So here author says that the radioactive decay could transmute one element to another, a conversion previously thought possible only in the dreams of alchemists. So the discovery of radioactive is something which surprises scientists, and its transmutations only possible in dreams, not in reality. In the process, mysterious beam of energy were emitted from the source material, beam that were at first mistaken for a type of light but soon revealed to be something else together. So what is the meaning of emitted? So it means emit, what it means, the past, to send out a beam of noise or smell. Okay. So here what author says, in the process, mysterious beam of energy were emitted from the source material, beam that were at first mistaken for a type of light but soon revealed to be something as altogether. So how it's discovered? Firstly, there is a mysterious beam of energy uh, coming from the source material, which people firstly mistaken as a type of light, but it's revealed something as. By examining the extent to which these radioactive emissions were able to penetrate other materials, scientists realized that there were different types of decay. What is the meaning of penetrate? Means to move into or through something. So here author says, by examining the extent to which these radioactive emissions were able to penetrate other materials, scientists realized that there were different types of decay. So when they are examining about the radioactive light, its penetrations and its emissions, they realize that there is some different kind of decay as well. And that is, first, the alpha decay resulted in emission that could be blocked by a thin sheet of the paper, whereas the gamma decay resulted in emission that could not be stopped by anything short of a very thick layer of the lead. So, by examining, scientists found out that there is two kind of a decay we get from the radioactive emission. The first one is alpha decay, where the resulted emission can be blocked in thin slices of paper, but in gamma decay, the emission is not even stopped by a very thick layer of the lead. So, what the title should give in to this species is a brief about a radioactive discovery. And what we can take, important point we can pick from here is that, firstly, surprise scientists transmute one element to another, a conversation previously thought possible only in the dreams of alchemists. In the process, mysterious beams of energy were emitted from the source of material, beams that were at first mistaken for a type of light but soon revealed to be something as together. Able to penetrate other materials, scientists realized that there were different types of decay, no, material, that's it, and it's different types of decay. First is alpha decay, which resulted in emission that could be blocked by the thin sheet of paper, and the gamma decay resulted in emission that could not be stopped by anything short of a very thick layer of the lead. Let's moving toward the next species. In terms of penetrating power, a third type of decay, beta decay, was neither exceptionally weak nor exceptionally strong. These emissions could penetrate paper but not sheet of metal. But the early sorry, but the early 1900s, scientists knew that beta decay was a process that emitted electrons. But experiment on these emitted electrons raise a mystery of their own. Whereas other type of radioactive emission always had a discrete amount of energy which was characteristic of the source material, the electrons that were emitted during a beta decay took a continuous range of energy values. This result, which was called the continuation B spectrum, means that if you took two electrons that had been emitted from the very same source material during a B decay, one of these electrons sometimes had less energy than the other, and the difference in the amount of energy between the two electrons varied. So what author trying to say here is that in terms of penetrating power, a third type of decay, beta decay, was neither exceptionally weak nor exceptionally strong. So here author talking about the third type of a decay. Earlier we just got to know about the alpha decay and gamma decay. Now here author is talking about a beta decay and how it works, and it is not extremely strong and not extremely weak. So how it is? These emission could penetrate paper but not sheet of metal. That this emission, this beta decay emissions could penetrate the sheets, paper sheets, not the metal sheets. By early 1900s, scientists knew that the beta decay was a process that emitted electrons. So in year 1900, scientists discovered that or get to know that the beta decay can emit the electrons. But experiment on these emitted electrons raised a mystery of their own. So here comes the mystery through the experiment. Whereas other type of radioactive emission always had a discrete amount of energy which was characterized of the source material, the electrons that were emitted during the beta decay took a continuous range of energy values. So here author says that in earlier experiments there always some source of energy or source of material through the energy discreted. But in the electron ones there is a continuous range of energy, not in any stable or weak. There is a continuous changing range of energy. This result, which was called the continuous B spectrum, means that if it took two electrons that had been emitted from a very same source material during B decay, one of these electrons sometimes had less energy than the other, and the difference in the amount of energy between two decades varied. So here author is saying that the result of the experiment with beta decay with electron as well, that it's called a firstly continuous B spectrum because it's continuously varied in the range of energy. If you took a two electrons from the same source, it is a very possible that one is having a less energy, other is high, and always the difference between these two energies is always different. So, what the title should given to this particular thesis is a brief and experiment about beta decay. And what the important point we can take from here? Firstly, neither exceptionally weak or nor exceptionally strong. Penetrate paper but not the sheet of metal. Beta decay was a process that emitted electrons. The electrons that were emitted during the B decay took a continuous range of energy value, and which is called the continuous B spectrum. Means okay, that the difference in the amount of energy between the two electrons varied. So let's moving toward the next spaces. Where did the energy that was present in one case and missing in the other case go? This was a crucial question because if it could not be answered, B decay would involve a violation of conservation of energy. Some of the greatest experimental physicists of the time revisited this surprising result again and again, but more than 15 years after the continuous B spectrum was first observed, it still wasn't clear what explained it. So here a mysterious things comes in the picture, or we can say the questions about a beta decade. Here the author is questioning that where did the energy that was present in one case and missing in other case goes? Where it goes? It is so obvious. This was a crucial question because it could not be answered. B decade would involve a violation of conservation of energy. So it is a very crucial question because if it's not answered, then B decade just violate the rule of conservation of energy. Some of the greatest experimental physicists of the time revisited this surprising result again and again, but more than 15 years after the continuous B spectrum was first observed, it still wasn't clear what explained in it. So still the physicists are not able to find the answer of where the energy goes. So we can just summarize this, not the title. It's not need to give a title and pick an important point. We just summarize the spaces that where the missing energies goes, and still the physicists are unable to explain it. Let's moving towards the third and last pieces of today's video. In early December 1930s, Wolfgang Pauli pens an open letter to a group of nuclear physicists who were gathering for a meeting in Tübingen in Germany. Pauli was just 30 years old but already well known for his work on relativity and foundation of quantum theory, including the Pauli exclusion principle. He had been puzzling over the continuous B spectrum for several years. Dear radioactive ladies and gentlemen, his letter began. I have, with respect to the continuous B spectrum, hits upon a desperate remedy. So this thesis is talking about a Wolfgang Pauli who penned down a letter to the nuclear physicist about a B spectrum. And he's telling about a desperate remedy. Means maybe he's just writing he's getting some answer which physicists earlier not able to get it. So what the title should give into this thesis is brief about Wolfgang Pauli. And what we can take from here is that write up pens on a letter to a group of nuclear physicists. His work on relativity and foundation of quantum theory. That's all. So we'll see you guys tomorrow with this continuation of this video. As of now, have a great day and happy learning.